Hello everyone, welcome to Basic Electronics Tutorials. In this video, I am going to take up the second numerical on Zener Diode voltage regulator. Let me read out the question first. For a Zener regulator shown in figure below, calculate the range of input voltage for which the output will remain constant. Assume Vz is equal to 6.1 volt, Iz minimum is 2.5 milliamperes, Iz maximum is 25 milliamperes and Rz is 0 ohms. Coming to the circuit shown here, we are asked to find the input voltage range over which the output will remain constant. The value of series resistance is 2.2 kilo ohms. The value of the Zener voltage of the diode is 6.1 volt and the value of the load resistance is 1 kilo ohms. Let us start with the solution part. Let us quickly write down the given values. The Zener voltage is given as 6.1 volt. The minimum Zener current is 2.5 milliamperes. The maximum Zener current is 25 milliamperes. Load resistance is given as 1 kilo ohm. The series resistance in the circuit is 2.2 kilo ohm. And the Zener diode resistance while it is conducting is 0 ohms. Right. We are asked to find the values of the input voltage range at which the output remains constant. So, we understand that the diode is reverse biased and is conducting. When the Zener diode conducts in the reverse biased mode, the voltage across it will be equal to the Zener voltage Vz, and here it is given as 6.1 volt. Let us now start finding the values for the input voltage range at which the output remains constant. This can be done by applying KVL to the input loop, which involves the input voltage source, the series resistance Rs and the Zener diode itself. That is Vin minus of Vz minus of Is Rs is equal to 0. Let me now rewrite this equation for Vin. So, Vin is equal to Vz plus Is Rs. Let me call this as equation 1. Coming back to the circuit, please note that the input current Is is the summation of the load current IL plus the Zener current Iz. Let me write that as an equation here. Let me call this as equation 2. Let me now substitute equation 2 into equation 1. So, equation 1 becomes Vin equals Vz plus Iz plus IL into Rs. Let me call this as equation 3. To find the load current IL, all we need to do is to simply divide the value of the load voltage by the value of the load resistance. Let us do that. IL equal to output voltage divided by the load resistance RL. Please note, output voltage is equal to Zener voltage and therefore the equation can be modified as Vz divided by RL. The value of Vz is 6.1 volt. The value of RL is 1 kilo ohm. Therefore, the value of the load current is 6.1 milliamperes. Please note, this is a constant because currently the Zener is operating as a regulator. Now, to find the minimum input voltage at which the output remains constant, simply put Iz equal to Iz minimum in equation 3. So the equation 3 now becomes V in minimum equal to Vz plus Iz minimum plus IL into Rs. Let us now substitute values to this. Vz is 6.1. The value of Iz minimum is 2.5 milli. The value of IL we just calculated and is 6.1 milli. And the value of Rs is 2.2 kilo. Computing this, you will obtain the answer for V in minimum as 25.02 volts. This is the minimum input voltage value. By using a very similar approximation, let us now find the V in maximum. To find the maximum input voltage at which the output remains constant, we simply put Iz is equals to Iz maximum into equation 3. So equation 3 now becomes V in maximum equal to Vz plus Iz maximum plus IL multiplied by Rs. Let us now substitute the values here. Vz is 6.1, Iz maximum is 25 milli, IL is 6.1 milli and Rs is 2.2 kilo. Computing this, you will find the value of V in maximum as 74.52 volts. This is the maximum input voltage for the regulation. So lastly, we can now conclude that the input voltage range at which the output voltage remains constant is 25.02 volt to 74.52 volt. That is the answer for this numerical. Well, with that, we come to the end of this video. If you found this video to be informative, kindly like and share this video and subscribe to my channel for more tutorials on basic electronics. Thank you for watching. Have a good day.